like to welcome everyone to our presentation. I'm starting things off with a brief introduction to Treehouse Software. We've been a mainframe software and services company since 1982. And since the mid-1990s, Treehouse has become primarily involved in the mainframe migration space. In recent years, though, our focus has become more on the mainframe to cloud market with our tcVISION data replication product. Our deep mainframe experience is our primary differentiator from the competition, and we developed active partnerships with all the most popular cloud providers and large systems integrators. Finally, we are an AWS technology partner, and you'll find our tcVISION product in the AWS marketplace. Also, we ask that you either hold questions until the end, since we have such a large audience, or put them in the chat and we'll try to answer as we go along. So now I'd like to introduce Chris Rudolph, Treehouse Software's tcVISION product manager. Chris will be presenting tcVISION and giving a live demo of the product showing data replication from our mainframe to AWS. Go ahead, Chris.
Thanks, Joe. Yeah, so as Joe said, my name is Chris Rudolph. I've been with Treehouse since about 1997. So closing in here on about 25 years worth of mainframe experience, working on these systems from IBM, ZOS, VM, VSE. I've worked with them all in various capacities, from an operational systems programmer level to a data movement level, which is what we do today. So for today's session, we'll take a look at tcVISION, and a couple slides here giving an outline of where we're headed. We'll look at some of the supported sources and targets, take a few look at some architectural slides, discuss the metadata mapping and modeling capabilities of the product, discuss some things with data replication, and then from there we'll go into a live demonstration of the tool. So the first slide I want to show here, tcVISION has been around now for since about 2007. Treehouse has been involved with it, helping all of our customers who we kind of pioneered our original change data capture methodology in the 90s, working with them on tcVISION to move data from a number of different sources on the mainframe, whether it's the IBM databases, DB2, IDMS, VSAM, or Software AG's Adabas, or the Broadcom databases, IDMS and DATACOM. We work with a number of customers in these areas to help move the data to all the various sources you see on and targets you see on this slide here. This kind of traditional Oracles and DB2 SQL servers of the world, as well as these days a lot of work in the cloud with the Aurora databases, with the Postgres RDSs, and then also branching off into other areas as well, such as Kafka and Kinesis, moving data to Hadoop, and then pushing data as well, not just SQL, but also pushing data to targets like Avro and JSON. And so we really have quite a tradition here of innovation with tcVISION to constantly add new targets, new sources to the system, and to be able to do all this data replication and data movement in a way that doesn't really impact the mainframe systems at all. So tcVISION, just a couple kind of ground rules here, has components that run on both the mainframe for ZOS and VSE, as well as the open platform, all the OSs you see here. When we talk about the open platform, we don't really care from a tcVISION standpoint or if it's on-premise or in the cloud. Historically, our customers are running everything on-premise. These days, everyone is now looking to move things to the cloud. And then finally, there's going to be a GUI control board, which runs on Windows. There are no green screens with this product that's moving all the mainframe data. So at a very high level, what you see here on the left-hand side is our mainframe, which is running any number of mainframe databases, DB2, IDMS, IMS, database, what have you, and also has various unloads that take place on the mainframe. And we have tcVISION running as a started task. So this is running in an environment here where it's able to talk with the databases on the mainframe side in their native format, whatever that might be. On the right-hand side, we have the AWS cloud. We have tcVISION Manager running in an EC2 instance. This is typically a Linux instance with tcVISION running. And this process here on the EC2 side is where all the data transformation takes place. So we have our capture agents on the mainframe piece, which are pulling the data from the live databases or from these unloads, whether it's going to be for the initial load or if it's going to be for ongoing change data capture, pushing the data in native format over to the cloud, where we're doing the data transformation. And then once we transform the data, we're going to any number of databases, whether in the cloud or on-prem. Like I said earlier, typically this kind of environment was an on-premise thing in a customer's data center. Now more and more it's going to the cloud. And controlling the whole thing is this box down here, tcVISION control board. This is running on a Windows instance, typically a user's workstation, where they're able to do a single point of administration for the entire system. So tcVISION's control board is able to talk to the mainframe manager. It's able to talk to the EC2 instance, and look at all the metadata information, look at the scripts that move the data for the initial load, as well as the change data capture, and monitor that whole process, whether it's just a traditional unidirectional from mainframe to target, or if it's a bidirectional type replication. Now, taking a little closer look at what's happening in these managers when it's performing the change data capture piece, we come to our tcVISION repository, which is typically a series of tables within a relational database. And this repository has all kinds of information on the source and target environments. So it's going to have all of the table names and column names for the target. It's going to have the data type information and the, for VSAM, for instance, it'll have like the data set names and the field names from a copybook. It's also going to have replication rules, which are going to describe how the data is moving from one system to the other. There's going to be any type of filtering involved, any type of special processing. It's also going to have all of the, all the rules saying my column called name in Aurora gets mapped to a column called first name on the IBM DB2 side, or vice versa. And then controlling this whole process and populating the repository, kind of care and feeding, is our tcVISION control board, which is the piece working with the repository. And then we also have command lines as well, if you wish to use it in that fashion. So a very high level screenshot here of the control board. As I mentioned earlier, there's no green screens within tcVISION. Everything is kind of monitored and maintained from the open platform side. And one of the neat things about the control board is that it's really opened up the whole replication process to people who don't have any type of mainframe experience. And about half the sites we have, actually, the people who are responsible for doing all the data replication don't have a mainframe background. So they're able to use this control board to go off and do metadata capture information from the mainframe databases, generate all the DDL structures to go to the target systems, all without having a mainframe background. Sure, they might have questions for for an Adabas DBA or for a DB2 DBA to say, what's the name of the database or what are the credentials I should be using for the logon. But once they're able to get to that metadata, they can define the whole thing just from the single point of here, the control board. So they can import all the metadata, they can set up all the processes to move the data, both for the initial load and for the ongoing change data capture, as well as monitor the whole process, making sure everything is working the way it's supposed to. So when you first get tcVISION installed, the very first thing we do with the product is go through a mapping and modeling exercise. The metadata is really at the core of tcVISION, because without correct metadata, you really can't move the data to the target or from the source in an intelligent fashion. You really have to understand that metadata to be able to properly, take the mainframe data and push it to where it needs to be. So with that in mind, tcVISION's control board features a metadata import wizard, which is just, a series of screens that guides you through the entire process of, what is the mainframe database you want to pull from, or what are the objects you want to pull, how do you want to handle the translations of the data, what do you want to call it on the target side, if you have an existing schema that you want to go to on the Aurora side or SQL Server, you can import that information to our repository as well. And then once you have the data in there, there's all kinds of wizards that are built in to, helps with normalization, denormalization, substrings, concatenation, all the various things we find with the mainframe data. It's pretty typical if you're working with VSAM data or IDMS or Adabas that you might have a lot of redefines in the data, or you might have kinds of crazy things where you have like a 20-byte alphanumeric character field, and then that contains some binary data in the middle. And when you're looking to move the data off the mainframe, you have to push it into multiple columns to properly represent that data. Or you have, the number of days since the customer's company was founded, and you have to be able to push this to a formatted date. All the various things you find within this mainframe data. tcVISION has tools built in. Many times you be able to use wizards that you can go and get the data and push it to the target in an intelligent fashion. Another thing we have built into the product is the ability to do record typing. So it's fairly typical in these mainframe applications for something like VSAM, is maybe written 30, 40, 50 years ago, where you have multiple logical files within one physical file definition. So tcVISION has the tools you need to be able to split that off into multiple targets. And then finally, one of the earlier slides touched on bidirectional replication, and the repository piece has the tools you need to be able to set up conflict detection rules. So if you are doing some type of bidirectional replication, you have the capability to be able to determine who's going to win and who's going to lose in that type of environment. And so just a couple screenshots here of a couple different pieces here with the wizard. Whenever we're looking to do the metadata import, tcVISION is going to be using whatever the native dictionaries are for the system. So in the case like a DB2 or a Postgres, we'll just be going against the database's dictionary itself. For other types of mainframe databases like a VSAM or IDMS, we'll be using copybooks. For things like IDMS or Adabas, we'll go against those databases, embedded data dictionaries. So however the data is defined on the mainframe side, tcVISION is going to interact with that mainframe database just like any other mainframe application would. What you're going to do after you step through these series of screens is you're going to wind up with something like this, where we have on the left-hand side our source meta information, and on the target side on the right, we have our target columns. Within the repository editor and the control board, which we'll see in the demo here in a little bit, you can go and you can double click on any of the columns you see here, any of the field names, and get all kinds of information about the various data type that you have on the source side or on the target side. You can double click on these lines to pull up various wizards. If you want to do something with filtering of data, you can do that. Or if you want to add timestamps to your target columns or target tables to determine whenever data is last changed on the mainframe, you can do this. You can also see other things in here, such as the shaded columns here, indicating that we have a repeating field structure on the mainframe side. So one of the things that tcVISION allows us to do during the import process is to decide if we want to, denormalize to a parent or normalize to a child. And of course, if you, say I want to, normalize it, and later on you change your mind, say you want to denormalize it, that's fine. The repository editor has the tools you need to be able to make those changes on the fly. Just a couple more screenshots here from our editor, the various wizards we have, for doing things like character string manipulation, date time conversions, SQL lookups, calling off user exit programs. These are all capable through our wizards we have, as well as the capability of generating the DDL we need to create the table structure on the target side. This particular example here, you just go and you click a button from your repository editor. tcVISION pops up a dialog box. You click start, and the whole table structure from whatever objects you have imported from the mainframe side will be automatically created on the target environment. So I guess it's probably a good time to also kind of talk about bidirectional replication, because one of the key things you can do with tcVISION is bidirectional. A lot of our customers, when they first get tcVISION, it's not something they necessarily want to do bidirectional replication out of the gate. Typically, there's going to be some sort of reporting scenario they want to go into, or they're looking to push data to another system. And it's only a little later down the road, once they've been using the product, that, oh, it's really important now that I get this data from wherever this target system is back to the mainframe. And typically, with the way mainframe applications are developed, you have, everything's kind of intertwined. So maybe you have a state's driver's license system, for instance, but it just doesn't do driver's license. It also has all of the hunting permits and all the fishing licenses are in there, and the child sex offender registries in there. And so when customers start looking to push this data to various targets, it's like, well, I need to maybe uncouple one part of this application, but everything's really tied together, and I don't want to do a big bang. So tcVISION's bidirectional capabilities are a nice way that you can actually be able to separate out the pieces you want to move to an open platform side while keeping the mainframe unaware that things are changing. And it's also important to note too that when we talk about bidirectional, it has a lot of different meanings for a lot of different customers. And for some sites, it's just a matter, it's a very straight, we have a structure on the mainframe side, structure on the open platform side, and they're both being updated all the time. In other cases, it's more like a giant circle. tcVISION sends data to Oracle, and then from Oracle, some other processes pulls it out and it goes over to SQL Server. And then from there, it winds its way from SQL Server, tcVISION sends it back up to the mainframe again. Other scenarios, it's, we want to send everything from our DB2 database on the mainframe to Postgres in the cloud. And then if I flip a switch, I want to now send everything from Postgres back to DB2, but I'm never doing both of them simultaneously. So there's all these different types of scenarios people have. And one of the neat things about tcVISION is it's so flexible. It's able to meet all these various requirements. Different ways of architecting the data. You can see here one-to-one, one-to-many, kind of a graphical implementation here, showing that you can take, whatever those mainframe objects are and split them off into multiple tables, take multiple tables, combine them back into a single one. Maybe you have a parent-child relationship going to a target. You can combine that back into a single record type on the mainframe side. We also have these other special database types here as well. Data warehouse replication, which is really well suited for types of applications where there's frequent archiving of data, but there's a need to do reporting on that data. So the data warehouse replication keeps track of everything changed from the mainframe and lets you know on the target side with the flag what's active in the mainframe and what's no longer active along with the timestamp of when it changed. The journal replication is somewhat similar, but it's more of an audit trail of changes taking place on the mainframe. So whatever the changes are taking place, adding records, inserting, updating, deleting, the journal replication is going to track this. You can also track it as well if you're doing change data capture out of a relational database on the open platform side, on-prem or in the cloud. And where this comes in super handy are scenarios where customers do bidirectional replication. It's fairly typical, unfortunately, that you have a new application being developed, and so tcVISION sending data from the new application up to the mainframe. And something happens on the new application that does something to break the mainframe. It might just be something as simple as, the new application uses upper and lowercase characters for particular code, and the mainframe only understands uppercase characters. So the journal replication is a really great way for the developers of the new application can go and see what changed, when it changed, and be able to determine, the scope of the data remediation that has to take place to repair that mainframe application, all without having to involve the mainframe team, without having the DBAs on the mainframe side going through a bunch of logs or running a bunch of reports to figure out what's happened. The developers have everything they need right at their fingertips to be able to do that remediation. My last slide here from the repository piece is conflict detection. And just one of the most common questions we have from customers doing bidirectional replication is, what happens if I have a scenario where the same change takes place on the mainframe and on the open platform side simultaneously? How is tcVISION going to handle that type of change? And the answer is tcVISION allows you to set a series of rules ahead of time between your source and target objects to decide what should happen. So if you're going to add data, there's already data there. You can throw it away. You can stop the whole replication process. You can change it and insert to an update and continue processing. And we have these functions, which we'll look at a little bit more detail during the live demo portion. So that's kind of the overview of the repository. The next couple of slides talking about the actual movement of data. And for tcVISION, we have two different ways we move data. The first is going to be an initial load or ETL process, where tcVISION is going to read whatever the mainframe data source is, or if you want to load data into the mainframe from a relational database from the IDMS. That's going to read that source database, or it's going to read an unload of the data from that source database, like a DB2 image copy or an ADABAS unload. And it's going to transform that data on the EC2 side and then load it using whatever the bulk loader facilities are into the target database. So if it's going to Postgres, it'll just do a Postgres copy, for instance. This whole transformation process is going to handle everything. So it's going to do all the transformation of the code types from EBCDIC to ASCII, and whatever types of rules you have built in the repository is going to use. There's not going to be any type of middleware requirements within the initial load. tcVISION is going to have everything you need to take that data and push it over to the target side. And one of the cool things you can do even is if you have, we hear from customers who have large amounts of data in the mainframe side, you say, well, for an initial load, you can just unload that data, whatever, using the mainframe database's native utilities to generate whatever that compressed file is, whether it's an image copy or an unload, and then transfer it over to the open platform side and process it there. So this initial load doesn't even have to use any mainframe resources. It can just be fully formed over on the open platform side. Now, when we talk about change data capture, tcVISION has different ways of getting that mainframe data, as well as the relational databases, to pull the data out of the database, capture it, and then queue it someplace safe before transforming it and applying it to the target environment. Typically, in a lot of cases, we're doing some type of log-based change data capture, so reading whatever the database's native logs are and pushing the data forward. For databases such as VSAM, which is really just an index file system, and there's no log, tcVISION is able to get the changes through a CICS or through a batch wrapper or through other means like IBM CICS-VR product. And the same thing is true for some of the other databases we support, whether it's going through log miners or going through the database's native CDC mechanism, like the SQL Server integration services for SQL Server. However we're capturing the changes, we're going to queue them temporarily on the file system of the tcVISION manager running on an open platform, and then we'll apply them to the target side. So we have this whole decoupled approach we're using for replication, and then we're using the same exact rules we use for the ETL process to perform the transformation of the data. So whatever we're doing with ASCII EPSDIC we did for ETL, we're going to do the same thing going to the target side, generating SQL, or whether it's JSON going to S3 or Kafka, what have you. tcVISION has some restart files it uses to track its process going through the source system, so it knows exactly where it left off. So there's some type of interruption in service. tcVISION is able to automatically pick up where it left off and continuing replication. The other thing to kind of call attention to for change data capture is this bullet point here, transaction safety. What we mean by this is that tcVISION is only sending transactions that were committed on the source side to the target. So if you have rollbacks taking place, tcVISION is just going to throw that stuff away. It's not critical for replication. And if you have, a transaction that's going across multiple objects, across multiple database files, or across multiple DB2 tables, tcVISION will generate SQL that's going to go across the same types of table structures on the target side. Or if you have a batch application that's updating, 50,000 rows at a clip, well, tcVISION will do the same thing, sending things over. So send 50,000 from the batch, and then you have an online user who sends a single transaction over that will have its own commit point. Whatever that unit of work is happening on the source side, tcVISION is going to honor that going to the target side. Now, the kind of the secret sauce here with the whole ETL and the ongoing change data capture piece is the ability of tcVISION to do the bulk of that transformation on the open platform side. And the secret sauce to doing that is the stage processing that tcVISION uses. So when it's capturing the data for change data capture, or it's reading data for an initial load, that's all happening in stage 0, where we have the data in its raw, mainframe-y type format. And then in stage 1, we're going to queue it on the open platform side, and we're going to separate it off into before and after images based on whatever that source layout is. And then stage 2, we're going to, as part of our transformation, we're going to transform that data into before and after images based on the target structure. So if we're going to some type of normalized structure definition, we'll have our before and after images based on that format. And then finally in stage 3, we're going to take the data and we're going to, format it for whatever the target side is going to be. So if it's going to, to Postgres, we'll generate SQL. If we're going to Kinesis, we'll generate, a JSON, or maybe we're going to Oracle. So we need to use the Oracle loader files. Whatever that target system is going to use, tcVISION is going to build it. So almost think of it, the stage 3 is a bit of a garden hose type nozzle. You just spin it around to use whatever type of data source or data target you need to have. Now, the other thing you do with the stage processing is to have the data queued in stage 1 to be able to send it to multiple targets. So in fact, you can just capture from a single mainframe database and send the data to different places. Maybe you go into SQL Server and to Kafka, to take an example from one of our customers. tcVISION certainly supports that, going to multiple targets from a single source. And so the last slide here in my presentation, before we get to the online piece, is just to kind of point out tcVISION's continuing innovation. It's not like other products where you have a replication piece, or this was written 20 years ago, and then whatever it did 20 years ago, that's the way it works today, no changes. tcVISION is constantly evolving to take advantage of new ways of capturing changes, to do different things to write to targets, to take advantage of new technologies. And just to kind of highlight a few of them here, for DB2, tcVISION is now able to capture changes from a ZOS DB2 database without actually having any started task running on the mainframe. So we can work directly with DB2 itself to get the changes over. Another thing we've innovated on recently is parallel replication based on a user ID or job name. So what this allows us to do are scenarios where you have a system that has a massive amount of inserts being performed at one time on source. The way replication works, you typically have to follow the old rule of whatever order things happen on the source side, they happen on the target side. And so if you have 50 processes all hammering away at that source database, inserting data, you have to go one by one. And so horizontal scalability really isn't an option. But with tcVISION's new parallel replication, we can actually now scale horizontally when we're loading, for these massive loads to push the data to the target side during replication. A few things on here as well, support for AWS parallel services. As it was a recent thing we did to help one of our customers out, where they have multiple nucleuses running in database in a parallel type environment. So now tcVISION is able to support that. And then finally, the other one here, which is pretty key, is the ability of tcVISION to capture DDL changes from DB2 and push those to the target. And we're very happy about doing that. It's always a problem doing change data capture where the source structure changes and now you need to do something to adjust to it. We're in the process right now of actually making this automatic as well for other systems such as Adabas. So with that, I'm going to exit out of the presentation and go into the tcVISION control board. So what you're seeing right now is tcVISION's control board. This is a Windows utility that's able to handle the administration of the replication, as well as the initial load. So on the right-hand side here, this right panel, we have our active environment. And I have two managers. I have one here that happens to be running on an EC2 instance in the Amazon cloud. And I can double click on it. Yep, and there we go. And get some information about my manager running. With my operating system information, some information here about the configuration, version information, where it's running, what have you. I can do the same thing for my mainframe environment as well. And I can see here's my mainframe started task name and my operating system level, ZOS. We have our load library where the code base that tcVISION is using, version information. I can also see logs as well. So I can click on these things and see whatever recent logs written off by the manager. Looks like a bunch of disconnects, reconnects from Chris. Here's as well some stats from a process that was running at one point, moving some data. We can also look at logs on the open platform side as well from our tcVISION manager. So it really just kind of gives us a single way to be able to connect to various systems without having to actually go and log on to the mainframe for one and log on EC2 for the other. Now I can see this EC2 Linux manager has a couple processes running on it. These are actually live replication processes. One is capturing changes from DB2 and queuing them to what we call pipe. It's a file structure for captured changes. And then we have a second process that's going to be reading from that captured pipe and pushing off to a target. So I can double click on these things and see some stats in terms of records in, records out, as well as some information about the changes that have been gathered, how they're being transformed. On the left side here is our Replication IDE, excuse me, where we have different pieces here for scripts for moving in data, initial loads, as well as our metadata repository, which is what we talked about earlier in the presentation. And there's other things in here we can see, data directories to see information about logs that may exist on the EC2 side, or file system where we're queuing the changes. So we'll take a look here now at the metadata repository, and this is the piece which we have previously gone ahead and imported some metadata into. So I have two systems here. One is Adabas, which is more of a hierarchical type database, and the other is DB2. And what you're looking at is the database 5.115. That's the file structure Adabas uses, and then connected to this are various tables we've generated, all related to this one Adabas file. On the DB2 side, if I scroll down here, we have more of a one-to-one type relationship between DB2 and the sources. So if I take a look now at the Adabas one, and we can edit here from our repository, open up our repository editor, and you can see an example similar to what we saw in the presentation. We have our Adabas file on the left here, and then we have our target table on the right. I can also pull down some other related fields as well on here. We have language, and if we scroll down a little farther, you can see we have some coded fields here indicating we have some repeating field structures, and we have language is also a repeating field. So tcVISION for this type of thing is maintaining a parent-child relationship between the table structures it creates. You can see we have little keys here to indicate what's the key values. We can just double click on any of these things here to see some data type information on the target side for our Postgres demo Lang employees, fixed character. Do the same thing here on the mainframe side, and we can see this is fixed character length of 3, and then there's a subtable in here, and this is telling us here we're going to have 10 occurrences. And so you can do other things in terms of this product where there's options here if you have something normalized, and you can right click and there's options to break the subtable down. You can also click as well on the linkages between the various tables. So if I want to see the rules on name, for instance, if I want, I can set up some type of condition to do filtering based on the data type here for name. So param1 equals param2. So I'm going to set the current field, and then I will see everything that's set to Chris. Pretty typical thing that folks do, or customers do with this filtering of data is where there's record types involved. And so everything for record type A has to go to a particular target, and record B goes to a different one. Like I said, to be able to break the logical data types from a source, from a physical source such as VSAM into whatever their logical structures are. We can do this filtering both at the record level as well as the field level. And there's other types of filtering we have involved as well, greater than, less than, regular expression handler as well in here. So whatever changes you need to make. Now on the processing side, we have our wizard here that allows us to set various processing rules. So something that's pretty typical for customers to do is to set a value they want to have on each table. tcVISION generates a timestamp of whenever a change took place, either by tcVISION or the time that the change took place on the mainframe side, or the time that it was actually committed by the mainframe application. So these are things you can track within the product. If you're doing that, the general table replication I mentioned earlier, we have a function here, type of operation, that's going to track, to tell you what the transaction type was on the source side, insert, update, or delete. And there's other things in here as well. So we can do lookups to various pieces of exit code. We can do SQL lookups. Do various character string manipulation, so left, right parts of substring, change replace based on either a single word or a single character, regular expressions and SQL comments. As tcVISION, which we'll see in a little bit here, is capturing changes from the mainframe side. It's also writing off information about the transaction as well, what the job ID was, what the source type was. So it's actually able to get these things here, kind of the meta information surrounding the transaction, and push those to the source side, or to the target side. Another big thing is date time manipulation. So you come in here, and for some of the mainframe databases, like a natural or for AWS Natural or DATACOM, they have their own proprietary date formats types. tcVISION is able to handle the date structures on them, as well if you just have a standard, VSAM file with a year, month, day, you can specify that same type of format here that you're going to use for your presentation. Other things you can do within the product here in the repository editor, there's a button you can click, and tcVISION will go off and automatically generate all of the table structures, the DDL, on the fly in whatever the target system is. So all the create table, alter table, add the primary key, add constraints, specify if you want to have cascading deletes or cascading updates. You can all do that within this product here. A couple other things from the repository editor I want to point out. If you have I mentioned earlier the presentation conflict detection and bidirectional replication. So all those various types are defined here as well on the table-to-table type properties. So if you're doing bidirectional replication, you want to put a back update check-in, so you don't have an endless looping of transactions from the source to the target and back again. So you need some filtering here. If you're doing one of those other types of replication processes I mentioned, general replication, data warehouse replication, you can set it here. The conflict detection, you also set as well down here. So maybe you're doing updates and you say, for this particular application, I want to do a validation first to make sure that all the data currently existing in the target system matches this before image of my mainframe DB2 table before I perform the change. And you can come in here and set these rules up. So it's all done within this repository editor. And I'm showing you here the GUI way of doing these things, but we also have our command line tools as well if you want to manipulate these wizards, the repository pieces. The final thing I want to show here is just kind of step through a little bit of the metadata import, just to give you a little bit of a flavor of how that works. As I mentioned earlier, it's going to ask you a series of questions. What do you want for your source and for your target? Are you just importing just the input, output, or do you want to have tcVISION actually generate everything for you? You can specify our output target information in here. So we can specify whatever my database name is going to be. And then you go and select the type you want. So whether it's going to be AWS, we can come over here and we have a list of the various database types that targets that tcVISION supports, whether it's something on the Aurora side, Kinesis, Redshift, S3. We can do the same thing as well for looking at other database structures. Maybe it's going to be MariaDB or MongoDB. Yeah, tcVISION just kind of guides you through a series of screens where you can specify the connection information for those particular databases. Once you've gone ahead and defined your database structure, almost like Postgres, we'll come to over here, and then tcVISION is going to ask you what the database is going to be. So, for instance, for DB2, you can click through, and it's going to give you, the predefined DB2 connection you have, DB2 ZOS. Then tcVISION is going to go out and actually query the sysIBM tables and show you here's all the DB2 options available. You can see we have a little superscript one for those tables that have the capture flag activated. I can select one of these, and tcVISION says, "Oh, you don't have the capture flag. Do you want me to go ahead and set it for you?" Another example, if I come back here, would be Adabas. And so if we take a look at Adabas running on the Treehouse mainframe, we specify our host manager here for Adabas, specify our data dictionary information. Then tcVISION is going to go through and give us a listing of here's all the files I have available on my Adabas environment. I can select vehicles, for instance, and then tcVISION is going to, or US person, is going to step through a series of screens here asking me what do you want to use for your primary key. And then if you have any type of repeating fields, do you want to normalize them or denormalize them? What do you want to do if you have prefixing turned on for your mainframe sources? Do you want to add prefixes, remove prefixes, specify your code pages for EBCDIC and ASCII? And as you eventually drill down, you get to the point where you can specify whatever you want to use for your table name. So it's going to be, CTR, my US person. And select if you want to have the in upper or lowercase, say next, and finish. tcVISION is going to spin through the process, reading the mainframe metadata information, generating the target structure. Looks like this is completed. Say yes, we want to edit the repository entries now. And now we have our new information that's been imported from our Adabas file. We can click over here, see various pieces of information about our source that we're getting from Adabas, as well as all the stuff we were looking at earlier. Being able to see the targets, and click another button and say, do you want to create the table? Say start, and tcVISION is going to go through the whole process. It looks like it's probably complaining because I don't have schema CTR in my Postgres database. That's fine. So kind of starting to wind down here. A few more things I want to show is the scripts themselves, which are moving data. Let me take a look at a couple of these things here. As an example, I'll take a look at an ETL script. And so these scripts, what you're seeing here, this is our wizard that we're using. And we call them a script because it's actually generating a series of parameters that are going to be interpreted by tcVISION to move the data. And so our data source side, we're going to specify how we want to move the data. Bulk transfer means we're going to be moving the data for an initial load. We also have options here. We can specify the database type we want. So if we're doing change data capture out of IDMS, we specify our IDMS journal record as well as our connection information for IDMS itself. I'll change this back to bulk transfer. It has additional properties here in terms of what it is that you actually want to be able to read from. So select TRDA for DB2, and we can go ahead and check the boxes of what we want to import and to load. Specify our connection details, going to our DB2 database, and then finally what we want to have as our target here. So this repository just means we want to use whatever definition we have in our repository for our source and target. You could also specify, an actual direct connection to a database as well if you want to do a load directly into some type of target system here. For change data capture, we have our OEW manager, which is the piece I mentioned earlier about preserving the units of work taking place. So if we're in a change data capture scenario, this OEW manager piece is going to be the component that ensures that rollbacks are thrown away and we're only processing committed transactions to the target. So a fairly typical thing we do here during these presentations is just a little sample where we say, okay, we have we've captured 7 records out for this particular environment, and we have some stats here in terms of 7 updates for employees. So we'll come over here to our databases tab and we'll make some changes to DB2. And so we can take a look at our DB2 data here for demo employees and view our data. So we have a table here, and maybe we want to make a change to option number employee ID 3. We'll change someone's name from Joe Brady. And if we come down to our Postgres side, we'll connect to it. To our tcVISION schema, and we have our DB2 data over here, which is already pre-populated, and we'll update employee number 3. So we can do it either from our local utility, or if we want, we can also go from our mainframe. So this is what you're looking at here is actually the Treehouse mainframe, and I can do the same thing over here. Issue my select statement. Go ahead and run this guy. And we have Joe Brady for number 3. So come back here and we'll change this. Name to Rudolph. Chris. Thank you, mainframe. All right, so we'll just do and we'll run it. Looks like he's unhappy because I have. Go, yes, make the change. Now if we take a look here at our query again, now we have first name Chris Rudolph, and we come back over here to tcVISION, and we can see if we take a look at our stats, our counts have gone up to 8, and we can also rerun our query over here against the Postgres side. And now for number 3, we have Rudolph CHRS. So we've made the change. tcVISION has captured it in your real time, and now transformed it, pushed it to our target system. I'm going to stop the script, and we can take a look actually at its data log that was generated. Take a look at our good log. Maybe I can make this font just a little bit bigger. Maybe not. Okay, well, if I scroll down here, at the very bottom, we have our no commit, our update made in DB2 with our name information, employee, and then our commit. We also have these dashed lines here showing some comments. So we come out over here to the right, and we can see our DB2 type, TBID, OBID, version information for our schema, DB2 page information. Here's my CTR1 user ID, resource information. And then if I keep going to the right, here eventually we have the RBA. So the really neat thing is that, by going and looking at the data we have here, the RBA, you're actually able to tell from this log that we have generated here what the source was on the mainframe side. And we do this for all of our databases. So regardless if it's something on the mainframe side or open platform, if it's SQL Server, for instance, we'll have the LSN, or same thing with Postgres. For IDMS, we'll have a journal number. And so you have all the information here you need to essentially build up your audit trail to say, I have this change I've gone ahead and written to my target system. When did this particular change take place on the source database side? So that's my presentation. Joe, I'm going to hand it back to you again. maybe if there's some questions we can have answered.
Yeah, Chris, very good.